Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365. Today we are going to discuss about first order logic in artificial intelligence. Let's begin the topic. First order logic, FOL, is also known as predicate logic. It is a foundational framework used in mathematics, philosophy, linguistics, and computer science. In artificial intelligence, AI, FOL is important for knowledge, representation, automated reasoning, and NLPs. So, here was the reason. So, first order logic is also known as a predicate logic, right? So, it is a foundational framework used in various fields, including mathematics, philosophy, and linguistic and computer science, right? So, what are the importance in AI? So, we have the knowledge representation, automated reasoning, and natural language process. The key components of the include. So, we have construct. So, constructs we have here represent the specific objects like example, alias, to and network. So the constant that the purpose of constant is or used to represent the specific named objects in the domain of discover. Like we have example like names, anything like alias, like a name or a number or a city, place or refer to a particular individuality or entity are variables. Standard unspecified objects. Example, like we know the variables, right? If we don't assign any values, if we want to assign the values to store in the values, right, we assign the variables like X, Y, Z or A to the A, B, C or anything. So, those are the commonly used. So, purpose of the variable stands for unspecified or generic objects that are used when you want to make statement. They applies to any objects or an object whose specific identity is not known as relevant at the moment. Predicates define properties or relationships, example like Elias Bob and indicates Elias Bob's. Elias likes Bob. So here the purpose of the this is predicates defines the properties of the object or a relationship between objects. They are like functions that returns a truth like true or false. So here we can say we we use the or here. Essential we can use here like we can say Elias is for P and likes B for or and Bob for B like A or B. Like we use it like written use for in conjunction, disjunction, or biconjunction. Like in those we can use. Second, functions. Maps objects to the other objects. Example, mother of X and denote the mother of X. So both are the mother of X, right? So here we can say that the function map objects to the other objects, like unlike predictive, which returns true or false. Function returns an object. Example, mother of X denote the mother of X, right? So if X refers to the allies, then the mother of allies, like we go mother of allies would refer to the allies. Then mother of another specific object, like other example could be here some two, three, like which would return five, two of three, like that. So here capital of France, which includes the return in Paris. So like the examples we can use here. So most important thing, quantifiers. So define the scope of variables. So here we have universal quantifiers and extensional quantifiers. So we have the some quantifiers like we can say quantifier define the scope of range of the variable within the logic statement. They will use how many elements the like in domain to discover or satisfy the popular predict, right? So we have the symbols here, like of the these are the you quantifier symbols like reverse is all the quantifier symbols. So meaning of all for every for each applies or a predictable to all elements in the specified domain. Example of like we can say a person of screen say like we can say like that. So we can write here. Wait, I can write here through. So example for this. So I can write here. So if I take like this, uh, so I have a person, right? I have a person of X. to implies we use mortal, right? So here we can say this part may be represent as P, and here we use imply, and this part may be Q. So like the imply functions we can use, for example, or every for each like applies. So this statement means all persons are motets. It asserts that for any X, if X is a person, then X is also motel. So like that it's a next thing. And we have essential quantifier, like the symbol which denote has E, right? To reverse E. So for this we can take as same. Instead of reverse, we can take like this. So in this we can say here a person like, so I'm only mentioning P, not overall function. Okay. This here P is a, so this is P, this is X, right? So directly employs to Q of X. Okay. So this exists, there is at least one for same it refers like, okay. So in this function, we can say here, instead of this implies here, so we can directly, a person likes ice cream, like that, we can take here directly and we take it like this. Okay. So here we example person or likes ice cream. So we can so specify the statement means if example of a person of X and likes ice cream. Like the interpreter statement means someone likes ice cream. It efforts that therefore at least one. Like the optional, like here X is a person and X is a like ice cream. So here X is a person and here E is a ice cream. So we are optional like that. So we have logical connectivity, including conjunctions and disjunction or implications and biconditional and negations. So those are the what means conjunction means we all know a conjunction is a true only if all the statements is connected to true, right? So disjunction means what it is denoted by or a disjunction is true if at least one of the statement is correct truly, right? So implication if then implies and implicate P of P implies Q is a false like that. So P is true and Q is false. Otherwise remaining all true. Logical conjective. So including conjunction, disjunction, implication, right? We already discussed about. So meaning of implication if then implies and implies P2 implies Q. Like we P implies Q if it is a false. Only if only one condition is true, another is false, remaining all must be true. So in here we can say by conditions. So by conditions, nothing but if and only if, like if and only if, like if the both conditions like both true or a false, both if the both conditions are satisfied truth, then it returns truth. Negation, we know about negation, it is not. It is the opposite of the truth or the opposite of the false. If the value is truth, it must be replied as a not true, not truth, like that. So here we have syntax and semantic. Syntax and semantic of the first order logic. So first order logic and syntax defines how to construct valid expressions, while semantic assign meaning to them when interpretation provides to the domain of a discourse, assign meaning to the constant functions and prediction. So here we have example. For example, in the domain of the nature number, the predicates greater than x, y holds if x is greater than y. So we can say u x is equal to x equal to 5 and y equal to 3, right? So greater than equal to 5 of 3. So it's true. So you, obviously we can check that x greater than 5, right? So it's obviously true. If the x is 3 and the y is 5, then it returns to the false. So here are the order logic, like we can say, if x is an integer, like x is a subject and e is an integer, like x is a p and is an integer is a predicate. Like that. Here we go to applications of logic, first order logic in AI. So here we have knowledge representations and automated theorem proving and NLP natural language processing and expert systems and semantic web. So knowledge representation, encoding relationships and properties, such as in a medical diagnosis system, where predicates the defined symptoms and diseases. Automated theorem, right? It's verifying the software connectivities like connectionness and providing the mathematical theorems, natural language and NLP. So structuring and understanding the language for the tasks like machines translation and the questions answerings. Expert systems encoding the knowledge to interpret decisions like infer decisions, we can say that, such as the legal rules based on AI. Semantic web nothing but enhancing the intelligent web search by defining the relationship between the resources. So, example of logical relation with first order logic. Considering we can see all cats are mammals. Like we can see cats of X equal to the mammals of X. Like we can say the P implies on Q. So like that, mammals implies on animals. All mammals are animals. All cats are mammals, or all mammals are animals. So here we can say either false mammals and all. So we can say cat, Tom, and Tom is a cat. So like that, if P is a cat and Tom is a cat, so it implies we use the consider statements to implies on those. Okay. So from this we can interfere like mammals, Tom. Tom is a mammal. So in X place, we mentioned Tom, and Tom is a mammal. An animal of is it? Tom is an animal. So it is or. So dimensions of how FOL enables logic reasoning to divide the new knowledge from the external. So here we can say that like with the mammals or animals, all mammals and animals. Like we used to check that we can change the grammar. Advantage of the concept. So we have unifications and resolutions and model checking and logic programming, right? So unifications is used to use to finding the substitutions to make the two expressions identical, use it to automated reasoning, right? So resolutions, a rule of infer inference of a theorem, providing user to define conditionals or contractions, valid statements. And model checking is to verify the system correctness against the specifications applied in software and hardware verifications. Logic programs, we can say use language to prologue or detective or declarative AI applications in NLP and expert systems. Challenges and limitations. So here we have challenges. So computational complexity and expensiveness and why decidability and handling uncertainty. So here we have computational complexity of the reasoning, which a large knowledge base can be expensive. So here decidability versus expensiveness. So while powerful FOL is undecadable, meaning not all statements can be resolved algorithmically. So handling uncertainty is a first order logic lacks a probabilistic reasoning, requires the extension like fuzzy logic and probabilistic logics. So the overall conclusion, the first order logic is the cornerstone of the AI, enabling the structure of reasoning and knowledge and representation of device. Uh, should computation challenge, it remains the extensional in field like theorem providing NLP and expert system, enhancing all logical reasoning compatibilities. First order logic continues to the driven advancement in artificial intelligence. So I hope you guys all are understand about this FOL, first order logic in artificial intelligence. Thank you.